In this video, I want to have a look at the cosine rule. So the cosine rule is a relationship between the sides and angles in any triangle. So this here is written on your formula sheet. So the cosine rule is c squared equals a squared plus b squared minus 2ab cos c. Now, what's really important about this formula is that this side that's labelled c must be opposite this angle labelled c. So in here, we have to use this angle and this side as those values. Our A and our B are just the other two sides. It doesn't matter which order they go in, but this side must be opposite this angle. Now, what you're probably thinking, hopefully, is that this section of the cosine rule looks incredibly familiar, because if you just look at this section, then that's Pythagoras' theorem. The reason that works is if we have a right-angled triangle, CAB, that's little c, little a, and little b for our sides. If we were to substitute values into here, into the cosine rule, in this section we would get cos of 90 degrees because our angle is a right angle, and that's the angle opposite the hypotenuse. Now cos of 90, we know that cos of 90 is 0, so that would eliminate this whole section of our formula. So in a right angled triangle, the cosine rule just simplifies down to c squared equals a squared plus b squared, which is Pythagoras' theorem. All right, let's have a look at the cosine rule with a triangle that's not right angled. So in this example, we're trying to find the value of d. Now, our d is already opposite that angle 50. If we weren't given the angle opposite, we would have to find it out. But it is, so that's going to be our little c and our capital C. So we're going to have d squared is equal to our 7 and our 3, doesn't matter which order we put them in. So 7 squared plus 3 squared minus 2 times 7 times 3 times cos of 50 degrees. Then if we want to find d, we're going to take the square root of that whole thing in brackets. So you can figure this section out first and then take the square root, which is probably a good idea depending on which calculator you have. But we can just take the square root of that whole thing, and that's going to give us approximately 5.57. So you always need to check whether your answers make sense as well. So if this side's 7 meters and this one's 3, then a side length of 5.57 meters also makes sense. It works in that triangle. So that example was looking at finding the length of a side, and this formula worked quite well for that because the length of that side is on its own on one side of the equal sign already. Some questions though are going to want us to find an angle. So we're going to rearrange this, and you can rearrange it every time if you'd like, but you can rearrange it, and if you understand where it comes from and you remember how it looks when it's rearranged, then it saves you a little bit of work each question. So to rearrange this, I'm going to add this whole 2ab cos c to both sides. So I'm going to have c squared plus 2ab cos c equals a squared plus b squared. Now I'm going to subtract my c squared. So I'm going to have 2ab cos c equals a squared plus b squared minus c squared. And then to get the cos c on its own, I'm going to divide by 2ab. So cos c equals a squared plus b squared minus c squared all over 2ab. So this, like I said, you can remember this rearrangement, or you can go through and do this every time, and then we can substitute into there. So I've just written that formula up here. Now this question is asking us to find the value of this angle here, the size of this angle. So we're going to use this formula. Again, what's important is this is our angle that we're trying to find, which is our C. So that means our 8.6 has to be our little c in our formula. Then our A and a B, doesn't matter which one of these two it is. So we're going to have cos of theta is equal to 9.4 squared plus 10.1 squared minus 8.6 squared all over 2 times 9.4 times 10.1. Now again, you can figure all of this out. I'm not going to, I'm just going to do it all at once at the end. So to get theta, we're going to go cos inverse of this whole thing. And if we pop that in your calculator and round to the nearest minute, you're going to get 52 degrees and 11 minutes as the size of this angle. So let's have a look at two quick examples of the cosine rule.